Hi, in this video, I'm going to cover up some of the solved examples on linear coupled differential equation. So I have covered the concepts already in my previous video. I'm just going to quickly write in the formula that I'm going to use to solve for the x and y. So here we got the formula x and y equals to a times, let's say e to the power lambda 1 times t, uh, let's say here is p1 plus a e to the power lambda 2t p2, where p1 and p2 are the eigenvectors and lambda 1 and lambda 2 are the eigenvalues. So eigenvalues in p1, p2 are the vectors, and a and b are the constants that depend on the initial condition. So let's get started with this. The first thing is that I got to find out the eigenvalue and eigenvector. So when you're solving for dx by dt equals to x plus 2y and dy by dt equals to 8x plus y. So I'm just gonna quickly find out the answers for the a part, which is the finding the eigenvalues for this. So let's say if you got 1, 2, 8, and 1, as I said in the previous fragment, what we can do is to find the eigenvalues, you can just use the characteristic equation. That is, let's say if I take this as matrix M, so M minus lambda I, determinant is 0. And you don't need to do too much of the thinking here, because you could just use the shortcut. If I do this, I get actually just, if you got A, B, C, D as the matrix, the eigenvector, eigenvalues can be found out by A minus lambda, B, C, and D minus lambda, and equate this to 0, and you can find out the values. So let's do this. So 1 minus lambda, 2, 8, and 1 minus lambda here. And determinant of this equate to 0. So you get 1 minus lambda square equals to basically 16. So 1 minus lambda is plus minus 4. And so what we get is basically, so the value of lambda is 1 minus lambda if I take 4. So the value of lambda you get is 1 minus 4, which is negative 3. And once I take 1 minus lambda is negative 4, I can get lambda is 5. So these two are the eigen values. Now to get the corresponding vectors, you just put these values here. So lambda is negative 3 if I put here. So it's going to be 4, 2, 8, and 1 minus lambda, which is again 4. So if I take the x and y is my, let's say this is, here is the eigenvector. So this x and this y, please don't get confused with that. So I'm just trying to find out the eigenvector p1. So it'll be 4x plus 2y equals to 0. So if I take y equals to negative 2x. So if I take, let's say x is t here, if I take x is t, I get y as negative 2t. So my eigenvector here I can take is 1 negative 2 times t. So this is the basic eigenvector for once I get the solution for the eigenvalue lambda equals to negative 3. So for lambda equals to negative 3, I got the eigenvector as 1 and negative 1. You could take eigenvector as 2 and negative 4 as well. That's okay, but I take the least common multiple. So here what we got is, I'm just going to quickly write this down, is lambda is negative 3, and its vector is 1 and negative 2. And similarly, if I take, let's say now lambda as 5, because my second vector that I got is 5. So I'm going to take this as 5 here. So only these two numbers change. So if I take 5, 1 minus 5 is negative 4. And 1 minus 5 is negative 4 here. So you get the eigenvector in this case is negative 4x plus 2y equals to 0. So you get y equals to 2x. All right. Now here the eigenvector is going to be, if I take y, x as t here, my y is going to be 2t. It's the vector is 1 and 2. So my second vector that I got is, when I take lambda as 5, my vector is 1 and 2. So this is how you find the eigenvalues and eigenvectors. Now, as we know that the general solution of the equation is in this format, I'm going to use this to solve for the general solution. So let's see how do we do that. So when I'm solving this, I'm just going to first write down the dx by dt, dy by dt as x dash and x dash dot or y dot equals to, I can write in matrix form 1, 2, and 8, and 1, which we found my eigenvalue and eigenvector for. So now the general solution of this is given by this format, where you got lambda 1 and lambda 2 as the eigenvalues and p1 and p2 as their respective vectors. So when you solve this, the general solution of this will be xy equals to a e to the power lambda 1 is -3 times t, and p1 is 1 and -2 plus b times e to the power e to the power phi t times so next is e to the power phi t times the second vector is 1 and 2. So this is the general solution of this particular couple differential equation. Now to find out the general values for like given condition, you substitute the initial condition. So x is 0, y is 0, and initially x is 0 and y is 0 is basically 4. So let's see how do we do this. So when I take t as 0, I get x is 4 and y is also 4 equals to a times e to the power 0 is 1 and 1 -2 plus b times e to the power 0 is 1 and 1 and 2. So my equation is 4 equals to a plus b, and 4 equals to -2a plus 2b. So what we get is eventually when I solve for a and b and -2a and plus 2b, this is both 4. If I multiply this equation by 2, I get here 8. And if I add them, so I get 4 times b is 12, and b is going to be 3. And if I plug b as 3 here, I get, let's say, a is 1. So my general equation, the general solution is now actually, when I substitute the values of a and b, actually, so the value of a and b when I take, a is actually here 3 and b is 1. So this is actually my final general solution of this equation. So hope this is helpful.